Good morning and welcome to the plenary session of the second day of the conference on landscapes of our common future. It is both an honor and a pleasure to welcome you to the session, and I thank the organizers for giving me the opportunity to be here. The session is structured in the following way. We will have 3 keynote speakers, followed by 4 highlight presentations. And in the final session, we will have a panel discussion with 3 speakers. The session will be a 2-hour session. The 3 keynote speakers are Karen O'Brien, Nakicenovic, and Mimura. So without much ado, can I invite Karen O'Brien to present her keynote address. Karen is a professor in the Department of Sociology and Human Geography at the University of Oslo and has researched extensively on climate change impacts, vulnerability and adaptation, and in particular on how beliefs, values, and worldviews influence climate change responses and transformations to sustainability. Karen.
Okay, thank you, Purnamita. It's really great to be here in Paris, and I'd like to thank the organizers for giving me the opportunity to speak today. What I want to talk about is climate change as a challenge in managing risks. It's a challenge in managing risks that we ourselves are contributing to, where the risks are enormously high, and the timing and the quality of our responses really matter. So drawing on findings from the Working Group 2 Fifth Assessment Report, I want to talk about climate change risks in terms of an old game of risk, the new game of risk, but also the real risk that we face. And what I want to argue in this talk is that the biggest risk we face of all is the risk that we're addressing the wrong problem. Before I get to that, I just want to say something about risk. Risk is defined in the Working Group 2 glossary as the potential for consequences where something of value is at stake and where the outcome is uncertain, recognizing the diversity of values. We have a lot of really great research on the consequences of climate change. A lot of it is being talked about at this conference. We know a lot about the outcomes, and we know a lot about uncertainties. But it's when we introduce values and the diversity of values that things get a little bit more complicated in terms of managing risks. And that's because values influence how we perceive both the problem and the solutions. And I want to give you an example. When I was growing up, there was a popular board game called Risk, and some of you may have played this game. Risk is a military strategy game developed during the Cold War in 1958, and the goal is to occupy every territory on the board and in the process eliminate other players. A high value is placed on the values of competing, strategizing, conquering, and as with every game, winning. It represents a particular approach to managing risk, and it's one that remains very popular today. In fact, today kids are playing the game of Risk. They're playing Star Wars Risk, Lord of the Rings Risks, Plants versus Zombies Risks. And what I want to talk about is climate change risk and how these values can contribute to the way we're approaching it. So let's look a little bit more carefully at this approach to risk. The risk board depicts the world, a political map of the world divided into 42 territories grouped into 6 continents. In this strategy game, capturing a territory depends on the attacking and defending armies. In climate change, this would translate into resources and capacities. A battle's outcome is decided by probabilities, by rolling dice. As with our climate change scenarios, we can analyze potential probability outcomes with Markov chain and stochastic simulations and so on. Importantly here, though, the rules of the game neither endorse nor prohibit alliances or truces, in other words, collaboration among players. According to the Wikipedia description, which is my source here, is alliance making and breaking is considered to be one of the most important elements of the game as it adds human interaction to a decidedly probabilistic game. And adding human interactions to a decidedly probabilistic game then it becomes even more important with climate change because it introduces the potential and the possibility for individual and collective transformations that can actually change the game. And what I would like to argue is that we actually need game changers right now. So the challenge of climate change is better revealed through this, not a political map, but a temperature map, which shows what the world might look like by the end of the century. We see here two different potential scenarios, 2 degrees and 4 degrees. The 2-degree world is with substantial mitigation. The 4-degree world is without additional mitigation. These maps capture two very different outcomes from climate change with two very different levels of risk. The risks and outcomes that we will experience under either of these scenarios by the end of this century are dependent on human responses and interactions. This figure from Working Group 2 emphasizes the risks associated with climate change, and they're not just associated with the climate hazard. They're actually influenced by vulnerability and exposure as well, which in turn are influenced by socioeconomic processes, especially development pathways, governance, and adaptation and mitigation responses. There's a really nice animation of this figure on the Working Group 2 website, so I won't go into more detail. But what I want to emphasize is that the risks we're facing are not just about carbon dioxide. They're also linked to socioeconomic conditions that shape the ways in which we both create and experience risk. With this knowledge, managing risks means addressing the human dimensions of the problem. This requires better understandings of social change, of our potential for collective agency, our capacity to adapt, and most of all, our ability to transform systems and structures in a conscious and deliberate way towards sustainability. Now, many people point out that the climate has always changed and we have always adapted to climate change. But we know that the capacity to adapt is very much influenced by the rate, magnitude, and especially the timing of change, including changes in climate variability and extreme events, but also changes in socioeconomic conditions. Now, IPCC Working Group 2 presents an analysis of regional risks based on both research and expert judgment. And it considers the risks for the present, the near term, and the long term, using two scenarios for the long term, the 2 degrees and 4 degrees scenarios. And you can see here that the largest extent of the bar is the risk level with current adaptation plus additional adaptation to reduce risk, which is the shaded part. When we start to do this type of analysis and look at the global picture, and I don't expect you to look in detail at this, but more look at the patterns that emerge. Both risk and adaptation increase with higher scenarios of change. If we just pull out a few examples from this, regional examples, we see that in all cases, as temperatures increase, risks increase. And in some cases, adaptation can reduce the risks, especially in the current and the near term, sometimes with 2 degrees. But in these cases here, risks for Arctic ecosystems, North American wildfires, increased mass coral bleaching, heat-related human mortality in Asia, crop production in Africa, and water availability and flooding and landslides in South and Central America, we see that adaptation cannot do much to reduce the risks. In other words, there are limits to adaptation as a means of reducing and managing risk. If we focus on heat events in Europe, which is something that's very timely, we see that the risks are likely to increase even with increased adaptation. So these are only a sampling of the sectors that will be affected, and the maps do not reflect what we know about the distribution of the impacts of climate change. For example, we know that some groups will be more vulnerable to climate change than others. We know that the outcomes are occurring in the context of multiple stressors. We know that the capacity to adapt is not evenly distributed across society. And finally, we know that changes or responses in one region or sector will have influences on other regions and sectors. In other words, one group or sector's adaptation to climate change could increase the vulnerability for others. So the question is, can our old strategies of risks actually be used to increase and meet today's climate challenges? Now, if we look at the actual emissions curves and the potential scenarios for the future, we see that business as usual, the dark line where the 2014 estimate is actually leading us to the 4-degree scenario by the end of this century. And it's clear that holding warming to below 2 degrees is going to require some substantial transformations, not only in energy systems, but also in economic, political, cultural, and other systems. So given what we know about climate change risks, the question is not whether we can maintain warming below 2 degrees, but how do we do it? Well, we know that we need to reduce CO2 emissions, and it's clear, though, that the window of action for opportunity is rapidly closing. 65% of our carbon budget compatible with the 2-degree goal is already used. Fossil carbon reserves exceed this remaining budget by a factor of 4 to 7. So how do we keep carbon as unused? This is a big challenge. A recent paper by McGlade and Eakins shows that globally, a third of oil reserves, half of gas reserves, and over 80% of current coal reserves should remain unused from 2010 to 2050. These authors also conclude that development of resources in the Arctic and any increase in unconventional oil production are incommensurate or incompatible with efforts to limit average warming to 2 degrees Celsius. So what are we doing? Well, here's just a few recent headlines about drilling for oil in the Arctic. Basically, they're saying that Arctic drilling is inevitable. If we don't find it, someone else will. We may need it for the future. It can revitalize our economy, and well, we're in the oil game for the long term. And this really sounds much more like that old game of risk that I played growing up, with ambitions to limit climate change competing with vested interests and also big investments. So risk is not just about the diversity of values, it's also about whose values count, and it's also about power. So we seem to be following the values that are represented in the old game of risk. And this is exactly what was described in a recent article in The Guardian talking about the geopolitics of oil exploration in the Arctic. It says it could set major oil companies against each other, but also superpower against superpower as they scramble to exploit the last untapped giant reserves in part of the world where territorial boundaries remain unclear. No wonder some fear a new Cold War. Now, this approach to risk that we are going through and experiencing does not actually take into account the key findings of the IPCC Fifth Assessment Report, which concludes with high confidence that without additional warming and even with adaptation, warming by the end of the 21st century will lead to high to very high risk of severe, widespread, and irreversible impacts globally. So we don't seem to be doing a very great job of managing climate change risks. To do so, I would argue that we actually have to face the real risk. And for me, the real risk is that we are addressing the wrong problem. Here I draw attention to a distinction made by Ron Heifetz and his colleagues between technical problems and adaptive challenges. And this is something I've been working on for the last 5 or 6 years in relation to climate change. A technical problem is one that can be diagnosed and solved by applying or improving established knowledge, know-how, and expertise. And that's one of the reasons we're here in Paris, is to improve our knowledge and expertise. We seem to be actually approaching climate change very much as a technical problem. In relation to both mitigation and adaptation, there's a focus on developing renewable energy resources, building higher bridges and seawalls, breeding drought-tolerant crops, coming up with new insurance schemes, developing new international agreements, early warning systems, promoting innovation, and so on. And there's absolutely no doubt that we need these things, that they're important. But climate change is arguably much more than a technical problem. It's something that we can refer to as an adaptive challenge. Adaptive challenges are problems that draw attention to mindsets and ways of making meaning. They focus on diverse beliefs, values, and worldviews that we hold, both individually and collectively, which influence our identities, our interests, and especially our loyalties. Adaptive challenges almost always have technical dimensions to them, and so they can't be ignored. But unless the adaptive elements are addressed, technical responses alone are likely to fail. So in other words, knowledge and expertise are the key to managing technical problems, but beliefs, values, worldviews, and especially emotions are key to addressing adaptive challenges. So there are two important aspects of adaptive challenge that I'd like you to walk away with today. And the first is that adaptive challenges are personal. They draw attention to our individual and shared beliefs about the way that the world works, about how we relate to each other and to the environment, and also how we relate to the future. Many of our beliefs and assumptions are transparent or invisible to our own reflection and introspection, but nevertheless, they still influence how we both frame problems and solutions. Confronting adaptive challenges is often very uncomfortable because it threatens our identities and our interests, and it brings up emotions and feelings that we often don't want to address. In other words, it introduces instability and uncertainty in our lives. However, research still shows that we tend to see what we believe, and it's important that we recognize where our individual and collective blind spots might be when it comes to climate change risks. For example, we hold many implicit beliefs about human agency, whether or not individuals can influence the systems and make a difference in the world, or whether everything is just simply determined by forces outside of our control. For example, some people believe that consciousness and free will don't really exist, and that everything is determined by natural and physical processes. Some people believe that even if we have agency, larger structures and systems are constraining our actions, so we really don't have much agency. Some people believe, though, that there is a close relationship between individuals and systems. In other words, we are the system. And some people, especially physicists, believe that there are multiple worlds where every action and decision is actually being realized in an alternative universe. So whatever one believes, climate change can give us clear evidence that we do actually influence large, complex systems. That's what we are actually finding the attribution for. And this suggests that we may and do have the capacity to influence complex social systems as well. So the second characteristic of adaptive challenges is that they are political. They involve challenging the given. In other words, what we take for granted or what we consider as just is. This involves challenging existing orthodoxies, including assumptions about determinism, materialism, capitalism, consumerism, and all the other isms that you can think about. Adaptive challenges draw attention to different ways of knowing, being, and doing. And this means that it might mean challenging traditional notions of power, creating different alternatives, looking at the role of collective agency and collaborative power. And there's a lot of exciting research coming from the social sciences and the humanities that suggests that we actually do have a lot more agency and potential for collective change than we think. This includes research on social networks, on post-structuralism, post-humanism, new materialism, quantum social theory, post-oppositional politics, and so on and so on. And this research shows that small changes can make big differences, and that individuals, especially when working together, can generate rapid social change. So climate change is definitely not a post-political issue where we just have to, hold our hands together and say, let's get over our differences and cooperate. Instead, we need to make these differences in beliefs and values really clear, and then use both personal and political transformations to promote systems change. I want to conclude by just emphasizing that transformations are happening one way or another. When you look back at those curves that I showed, the 4-degree world is going to be a transformational, different world to live in. The challenge of managing risks then for us is really about what types of risks we're willing to accept and tolerate. What types of values are we prioritizing? And most important, whose values count in deciding what type of future we're going to have? And so bringing in the personal and political is really important because our responses to change are never neutral. If we want to avoid the risk of severe, widespread, and irreversible global impacts, we need to approach climate change as much more than a technical problem. We also need to adapt, to look at it as an adaptive challenge. In other words, adapting from the inside out. We do need to develop renewable energy, change infrastructure, develop better early warning systems, and so on. And we tend to be really good at technical problems. Maybe that's why we put a lot of emphasis on it. But if we ignore the adaptive elements of the problem, it's pretty unlikely that we're going to create the conditions for transformation at the rate, scale, and especially the quality that are needed to meet the challenges of climate change. So approaching climate change as an adaptive challenge means taking humans and human interactions seriously. And this calls for truly integrated global change research that recognizes the role of the social sciences and humanities in addressing the risks associated with climate change. The Future Earth, a global change research initiative, is doing exactly this, and I encourage everybody to get involved. And I'll end by saying that we know that climate change risks are serious. But the real risk, I think, is that we don't take ourselves seriously enough in the way that we approach climate change. If there's one message I have, is that humans are not just the problem in relation to climate change, we are the solution. Thank you.
Thank you, Karen. It is now an honor to introduce and welcome Professor Nakicenovic, who is the Deputy Director and the Deputy CEO of the International Institute for Applied Systems Analysis and Professor Emeritus of Energy Economics at the Vienna University of Technology. Professor Nakicenovic is well known for his work on sustainable energy, particularly an expert on long-term patterns of technological change and the evolution of energy, information, and communication technologies. Professor.
Good morning, ladies and gentlemen. Good morning, colleagues, dear friends. First of all, I would like to thank for this kind introduction, but especially for the invitation to have the opportunity and privilege to speak at this very important meeting. The topic I was asked to speak about deals with the conceptualizing our common future, and basically one of the major tools that we have for doing that are the storylines and scenarios. And the reason is very simple. The future is indeterminate, and it depends on our intentions. It depends on what the actions we'll be making, and this is why storylines and scenarios in general have to cover a very wide range of future possibilities. Now, let me start. I will be anchoring my presentation quite a lot in the area of the global of IPCC. I just see that the slides I have is the old versions, not compatible with 18 minutes, so I may just very, very quickly skip to the slides I was intending originally to eliminate in the presentation. There are a number of challenges. One is the access, that essentially 40% of humanity is left behind in the Industrial Revolution. There is an issue of improving security, dealing with climate change, and also with the air pollution. So these are some of the challenges. And these challenges have been captured in many of the scenarios. In terms of the climate change, I would say that the work goes back over 30 years, back to the first Earth Summit. At that time, following the Earth Summit, there were a number of events. Let me just mention the meetings in Villach that led to a publication of Scope in '86 by some of our colleagues from IASA, like Bo Deus, Gilles Jäger, and Bert Bolin. I think this is one of the first scientific publications to us calls for an assessment of climate change. We at IASA have been also working on those topics for a long time. There is the carbon report we produce, then the energy report that also deals with climate change, the Sustainable Development, a very famous book, and the publications on the impacts of climate change on various sectors. Now, I think when we think about conceptualizing the future, we have to think about the history and the future of some of the major drivers. And I will just mention two. One of the powerful ones is the population growth. Shobhakar Dhakal will talk about that. From 7.2 billion people in the world today, more than half lives in the cities, and it's probably going to be on the order of 7 billion toward the middle of the century, accounting for about 1/3 to 1/2 of the carbon budget that Karen mentioned in her talk. Now, so in 50 years, the world might look like the most industrialized countries where almost everybody will be living in the cities, and the process is accelerating very, in particular in the parts of the world that are developing very fast. So this is posing a number of issues. Let me just show you a second global development that one has to worry about in scenarios, and that is the carbon budget. And I'm trying to show it in the same terms as demographics. So today, as you can see, we are roughly half the way through the carbon budget, also based on the IPCC findings. So we have another 1,000 billion tons of carbon to emit from here to eternity if we want to stabilize at the normative goal of 2 degrees Celsius. So you might be wondering that I don't know how to plot test curves because it stops before 100%. Well, actually, that's not the case, but the reason is that such scenarios have a substantive overshoot in the short run and need negative emissions in the long run to stay within the budget. And 20% cumulative, this is a tall order. Part of it has to be done through afforestation, part through biomass in conjunction with carbon capture and storage, and there'll be a parallel session on these issues later on this afternoon that my colleagues from the Global Carbon Project are organizing. So this is the backdrop, and I think the challenge can be maybe done schematically presented this way. If you look at time, I would argue that the legitimacy of the business as usual has eroded. We know that there is an increasing problem perception. This meeting is very important in that process. Later on this month, the summit on financing in Addis, then September, Sustainable Development Goals in New York, and then COP again here in Paris. There is a growing number of actors that are doing the change. These are the good news, from cities to NGOs, including the scientific community. So one can hope that that will lead to new policy regimes and eventually also to deep changes in the values and norms. Because this is not just a technical issue. We need a deep transformation. We need to do more with less to stay within the planetary boundaries. And that will require also major societal and behavioral changes. So let me now, in the next few minutes, just as a film, show you how the scenarios have developed in IPCC. I think it's a very interesting story. Large scientific community has worked on that to produce these scenarios. These are the ones produced for the first assessment report. There are 2 baselines and 2 policy scenarios. What I would like to highlight here is that we have the history of 25 years, and the actual emissions have been on the top of the range. So we have seriously underestimated what the emissions would be in the coming decades. This is the second assessment report, again, policy and baselines. You can see that, again, history has been in the upper range. These are the SRES scenarios that we developed for the third assessment report with 6 modeling teams resulting in 40 scenarios. And again, the history has been above the median. And so hopefully Paris and all of these processes this year will change that trend into a peak and then downward decline. These are the scenarios that have been produced then for the fourth assessment report. These are the mitigation scenarios based on SRES. And I would just like to point out to one feature that may sound trivial. When you have a normative goal of stabilizing, for example, at 2 degrees, which is the green band of scenarios, then you eliminate about half of the uncertainty about climate change. Because in the first approximation, half of the uncertainty in climate projections is because we don't know on which development path will be, and half of it because we don't know how the Earth systems will exactly react. So if we choose the pathway, we eliminate half of the uncertainty. In the fifth assessment report, 1,200 scenarios have been analyzed in the literature. At the time of SRES, we analyzed 1/3 of those. So the literature, the scientific community has been working very hard, and we have a deeper knowledge now, both about the drivers and the outcomes. And again, the green band is very important. That's stabilizing at around 2 degrees Celsius. Now, in the fifth assessment report, based on that literature, there have been quite a lot of attention of understanding this lower band. So, because it's a tall order, we have to achieve deep reductions. And if we do not do that in time, again, we are back to the need for the net negative emissions in the second half of the century. So this is one story that is staying with us. One of the key scenarios that was developed, these are the so-called representative concentration pathways. This is a 2-degree case. There have been then 3 higher ones that stabilize at significantly higher levels. I will not go into the details, so I'm trying to illustrate that there has been a big handshake between different communities to produce scenarios, climate outcomes, and look at the possible impacts and adaptation strategies that have to do with that. And then the other thing that has been done during the AR5 by the scientific communities, and Karen has alluded to that. Also 5 so-called shared socioeconomic pathways have been developed that have a deeper stories about the main drivers. There are 5 of these that have been done by many modeling teams around the world. They include the narratives. I think this is very important to tell the stories, how these 5 pathways may emerge. They have analyzed the driving forces. I've shown the population that Shobhakar Dhakal will talk about later in this session, GDP, and so on. These are the major drivers, and then the question is what outcomes those developments will have in the energy sector, in the land use, on the technology, and so on. And finally, what are the emission outcomes of greenhouse gases, aerosols, and other pollutants? So this is a work that has been partially completed, but it's ongoing, and I expect this is something on which the community will be focusing over the coming years as well. So one of the major challenges is not just what needs to be done, but also how. So the modeling communities and other experts have been working very hard of understanding a little bit better what policies are required to go from these SSPs down to the various stabilization levels, including the 2 degrees. So that's basically the ongoing work. Now I'll do something very daring over the next few minutes. I will compare some of the INDCs that have come in to the scenarios, just to see. And this is, please treat this as a very ad hoc first order approximation, but I think it's still interesting. So EU, as you can see, these are the emissions of the EU countries. They have been relatively flat and decreasing most recently. And the green and blue bands are the scenarios of the Global Energy Assessment and IPCC that stabilize at 2 degrees. Now, this is the pledge, about 40% decline vis-a-vis 1990, and 80 to 95% decline by the middle of the century. And this is the RCP 2.5. So you can see it is in the right order of magnitude if the policies can go beyond 2020 and 2030 and go to a more rapid decline, because like you can see here too, we dip into the negative area. US has also made a very ambitious pledge. In US, the emissions have also declined most recently. And again, the future scenarios for US for the 2-degree stabilization. Here is the pledge, reduction of about 26 to 28% by 2020, and reduction of about 80% by the middle of the century. And here is the RCP, 2.6 degree scenario. So you can see this is also the right order of magnitude, I think, if we manage to move in that direction. And then last, but certainly not least, I would say a very heroic effort that has been just submitted by China, in particular because you can see that during the last decade, the Chinese emissions have grown explosively, putting China as the #1 emitter in the world. And you can see the full spread of the scenarios for the 2 degrees, both from Global Energy Assessment and IPCC, era 5. This is the pledge. About 25% increase with a peak in 2030 or before. And I have just looked at the article from colleagues, just published from the colleagues in China, that look into the possibility of how those emissions might develop in the future if we stay with the same type of ambition of policies. And I think that's very important. So if the policies pertain and there is a deeper structural change of the energy system beyond 2030, then one can be hopeful that the emissions would even decline below the current level. So I would say these are some really positive news, even though it has been very, very difficult to turn the trend around, as you have seen historically. So let me just spend a little bit of time on the issue of negative emissions, because it plays such an important role. But please be aware that the scenarios contain a large portfolio of policies, efficiency being one of the most important one. But because we are so late in mitigating, we will need negative emissions by much of the scenarios in the literature. So the red vertical line on the left are the positive emissions end of the century across the scenarios. On the right are negative emissions at the end of the century, meaning lots of BECCS, biomass and carbon and storage, and afforestation and other measures. Now, and you can see how the scenarios cluster. There are many that have negative emissions and many that don't. Now, if we look If we look at higher than 60% probability of reaching 2 degrees, you can see that the scenarios have quite lots of negative emissions. Let me just show this to you in a little bit more detail. So below the red line are the scenarios that are 1.5 degrees and below in the yellow region. Above the top red line are the scenarios that are above 2.8 degrees. So I think what is really interesting is the band in between. And if you look at that band in between, many scenarios have negative emissions. So this is something that we have to face because we are so late with mitigation. If you look above 2.8 degrees, there are very few that need the negative emissions. And below 1.5, there are very few scenarios. So that's probably something the scientific community has to look into over the coming years. I would like to conclude slowly by saying that we should not have climate-only or development-only policies. We need integrative policies, and also Karen has mentioned that. And one of the processes that I think climate discussion needs to be linked to, and climate processes, for example, energy. The Sustainable Energy for All has been a new initiative of Ban Ki-moon that involves private sector and public sector with the 3 goals: to connecting the 3 billion people who live in poverty because they do not have access to clean energy for cooking, leading to some 3 million premature deaths, doubling energy efficiency improvements, this is a really key goal, and doubling the share of non-carbon sources such as renewables. Very ambitious, aspirational, but I believe achievable, and the achievable is based on the Global Energy Assessment that has been conducted by 300 authors, and I know many are here in the audience, so let me thank them for their contributions. In this report, and this is just the executive summary, the scientific evidence is given that that can be done with the right policies, and what I'm particularly happy about is that these 3 goals have found way in the goal number 7, Sustainable Development Goal, and this is one of the 17 goals that have this quantitative orientation. So we do need to link to the other processes. Let me just show you why, in my view. This is based on the work of my colleagues at IASA, but has been also vetted with many models in the IPCC AR5. On the vertical scale, you have the global economic output. Today, we live in a 100 trillion economy, 7.2 billion people in 100 trillion economy. One of the goals is improving energy security on the left, and you can see the blue band is the variation across the models. On the order of 200 billion will be required on an annual basis to do that. To eliminate air pollution, an exceedingly important goal, between 400 and 600 billion per year. And for climate change, for stabilizing at 2 degrees, uncertainty is higher, somewhere between 700, 800, or 1.2 trillion. So, but the story goes on. If we look at integrated policies, and that was the analysis done here, if we do this jointly by looking at the multiple benefits that one can achieve, the total cost would be significantly lower. So it would be sufficient to stack up the cost of security and air pollution elimination together, and one would get a climate goal for free or the other way around. I think this is really important, and this points out to the need, in my view, to link many of these processes, in particular the 17 sustainable development goals with the climate. As Thomas Stoker yesterday said, you cannot achieve many of the 17 goals without having the right climate policies. I think this is a very strong implication. We have tried to work with the tools at IASA of understanding those multiple benefits based on the scenario, many scenarios that have been developed. Of course, we'll not go into the details of that. I just wanted to illustrate to you, to have a help for the decision makers to move the levers and then have informed scientific information coming back at them indicating how the trade-offs and multiple benefits might work on. So let me conclude with this last slide. Last slide. We will have a session later on today on a new initiative called The World in 2050, a parallel session in the afternoon. This is an initiative of Jeff Sachs from the Earth Institute and his colleagues, from IASA, Pavel Kabat, and my colleagues at IASA, from Stockholm Environment Institute, Johan Rockström and his colleagues, and the Sustainable Development Solutions Network. We had a meeting, and as you can see here, there are 25 organizations that have offered to participate in this important study. Part of the work will be based on the modeling. Part of the work will be based on the storylines, because we don't understand all of the relationships between the 17 goals scientifically in detail, but one of the objectives is to reach those multiple benefits. Well, I see that I've run out of time, so let me just conclude here by saying that I really hope that this very important conference and the other processes this year will lead to very bold action and that we will stabilize climate at a level that is not too dangerous. Thank you very much.
Thank you, Professor. It's now my pleasure to invite the President of Ibaraki University, Ibaraki, Japan, Professor Nobu Mimura. Professor Mimura is well known for his work on coastal engineering and adaptation planning. He will discuss today about a very interesting topic, a weather-ready world.
Thank you, Chair, for the kind introduction to me. This is the quite honor for me to be here to give a plenary keynote address in front of you. And so I'd like to express my deep appreciation to the organizer for inviting me to this important conference. This morning, I'd like to talk about weather-ready society as a part of our common future. My presentation is quite simple, consisting two parts. And so let me start with the brief overview of the current situation of the society and the increasing climate weather risks. So this is a quite famous picture taken from the IPCC Fifth Assessment Report. And this diagram indicates the impact of climate change is already occurring, and they have been widespread, including the weather and the water disasters. So many parts of the world are suffering from the climate or water-related disasters like heavy rain, floods, landslides, super typhoon, droughts, and bushfire, and so on. So, so when we look at the history of the global average temperature change up to 21st and the end of the 21st century, for the past of the 160 years, we already have the 0.85 degrees centigrade increase in global mean temperature. And in the future, we would have the further increase in temperature, something from 1 degree centigrade increase to more than 4 degrees centigrade. So given the fact that the even of a small increase in the global average temperature, 0.85 degree, we already have the increasing impact of climate change. So when we look at the future, we have to prepare the further increase of the climate change and increasing trend of the weather and water extreme events. I also take these pictures for average surface temperature and average precipitation. This picture clearly shows the distribution. There is a large distribution of the changes of temperature and precipitation. So the occurrence of the extreme events would also have a very strong regional distribution. So I summarize this trend in a very simple schematic diagram like this. From the past to the end of the 21st century, we'll have the increased trend of the climate change and increasing trend of the extreme events. So our further society will face mainly two changes. One is the long-term climate conditions, and the other is the changes in extreme weather events. And as I noted just before, there must be a large regional distribution. So, in face to the such future risks, what we should do? What's the solution for the society to respond to these situations? Solution is to build a weather-ready society. In my definition of the weather-ready society, it is a society which can minimize the impact from climate change and increasing extreme weather events. So, again, I come back to the very simple schematic diagram. In the past, the ability of the society to respond to the climate hazards, that is the resilience of the society or adaptive capacity, in other words, was quite low. So the gap between the climate and the hazards and society's ability is quite large. So this gap represents the vulnerability of the society to external hazards. And for a long time, we made an effort to enhance the resilience, to increase society's resilience to narrow, to make the gap narrower. And in the future, if we succeed in the making this gap further narrow and enhancing the resilience to catch up with the increasing trend of the climatic conditions, then the gap between the external condition and the society's resilience, capacity of the resilience become very small. So this is the basic picture of the weather-ready society. However, if we fail in promoting, enhancing the resilience shown like the dashed line, then the gap becomes wider. So in such a case, the society should be weather unready. So here, the key point is how to enhance the society's ability of the resilience. So in order to analyze how to strengthen resilience, I draw a very simple two-dimensional diagrams. The horizontal axis is a time frame. The left-hand side is the short-term extremes, and the right-hand side end is the long-term climate change. And the vertical axis is for the countermeasures from physical to social and institutional measures. So the blue boxes represent the physical protection of the society, including the ecosystem and structure. Recently, many people emphasize the importance of the ecosystem, role of ecosystem to make our society healthy and safe world. So I include the ecosystem as a part of the physical protection of the society. And the green box represents the information provision through weather forecast, observation, monitoring, and early warning. And based on such information, we can develop the disaster risk management scheme. And the yellow part is the decision-making planning. And again, this decision-making and the planning is based on the information and also people's understanding and awareness of the risk of climate change and the way of the decision-making. The purple box, upper right-hand side, is the social policy to reduce vulnerability. To reduce vulnerability is a very basic condition for the weather-ready society through the policies like human development, poverty alleviation, livelihood security. So when we look at the such kind of diagram, we can understand that in order to strengthen resilience, we have to enhance the all the components of the resilience in the society. Recently, many reports emphasize the informed decision making. I mean that the green box in this diagram. I fully agree with the importance of the informed decision making. At the same time, I want to point out the importance of the physical protection. Next slide, please. Okay, thank you. So I'd like to use the example from Japan, lesson learned from the extraordinary tsunami damage in Japan, which happened in 2011. Obviously, of course, the tsunami is not a climatic event, but we can learn something from this extraordinary tragic event. The area hit by tsunami had been protected very strong, very high coastal protection structures. However, the tsunami overflowed and destroyed coastal dikes. So after this experience, people say that we still need dikes, but cannot rely on them alone. So then we set the two targets for tsunami protection. First one is against maximum cross tsunami, like this time, and we call this tsunami level 2 tsunami. And in this category, priority is on the saving people's lives and by using the early warning and evacuation. The second target is the relatively frequent tsunami with smaller height. We call this one level 1 tsunami, and the purpose is to protect people's lives and assets by using the coastal structure. So the diagram of the down side indicate the historical distribution of the tsunami occurrence in some part of Japan. You can see the red point is the extraordinary high tsunami, more than 6 meter height, and while the black line, black dot indicate the more frequent occurrence of the smaller tsunami. So against this black line, we can use the coastal dikes to protect inland area, while the for the red one, people have to evacuate by knowing the early warning. So I think that that kind of concept can be applied to the future weather-ready society. I mean that the role sharing of various measures, including hard and soft countermeasures, are very important. Hard measures can protect the society from the loss of lives and assets, but it cannot work for extraordinary events. While the soft measures is very effective to save lives, but they cannot protect people's assets and the economic activities, even in the smaller events. So role sharing among range of measures is essential to make the society weather ready. And second point I want to make is the importance of the informed decision making. I already touched upon this issue, so I don't need to repeat again. But through the provision of information by weather forecast or systematic observation or monitoring or early warning system is very important as a support for the weather-ready society. In the information, as many people identified, the local, traditional and indigenous knowledge is also important for local community to respond to the future threats. So, last thing I would like to mention is to avoid limit to adaptation. I'd like to come back to this simple diagram again. And in the future, if we do nothing, the climate change will proceed in a larger scale, and also the extreme event may increase, as indicated in the red line in this diagram. And if we fail to promote the society's resilience, then toward the end of this century, the gap between the climatic condition and the society's responding ability becoming larger and larger. So then the role of mitigation is to control the proceeding of the climate change within the level manageable for the society. And the role of adaptation is to increase, to enhance the ability of the society. Then both strategies jointly work together to minimize the gap of the climatic condition and the society's resilience. However, in the IPCC Fifth Assessment Report, we identified there must be some limit to adaptation. So the role of mitigation is very, very important to regulate, to manage the proceeding of climate change within that range. So far, I mainly talk about the adaptation side, but the weather-ready society is not only based on adaptation, but also heavily rely on the mitigation, as I mentioned right now. So this is the kind of a summary of my point. First one is key to build a weather-ready society is how to enhance the society's resilience. For this purpose, role sharing among range of measures is essential to make the society weather-ready. And the relative importance of each measure is heavily dependent on the social conditions and the context of each society. Informed decision-making is also important, and the greater rates and the magnitude of climate change increase the likelihood of exceeding adaptation limits. So, weather-ready society is not only based on the adaptation, but also heavily rely on mitigation. Lastly, to ensure safe and secure environment, weather-ready society is an important part of our common future, sustainable world. And from the tomorrow morning to this morning, many speakers point out that the climate change cannot be handled alone. It's the interconnected part of the sustainable world. So this weather-ready society concept is fully in line with that notion. So by saying that, I conclude my presentation. Thank you very much for your attention.
With that, we come to the keynote presentations of this session. I thank Professors O'Brien, Nakicenovic, and Professor Mimura for their contributions to the session, and I invite on stage our highlight presenters. welcome our highlight presenters. We have 4 speakers in this session. Our first speaker is Dr. Ricarda Winkelmann from the Potsdam Institute in Germany, and trained as a mathematician and theoretical physicist, a contributor to the IPCC 5th Assessment Report. She will be speaking to us about quantitative approaches to future impacts.
Yes, good morning. Thank you very much for the kind introduction. And I'd also like to thank the organizers, especially for inviting me here, for giving me the opportunities to speak today. We're very concerned with the impacts of gradual climate change on nature and humans, and rightly so. The roughly 1 degree warming we've experienced so far has already caused observable changes in the Earth system. The last decade has been the warmest ever recorded. Mountain glaciers are declining, the Arctic sea ice cover is shrinking, and we just heard that next to the impacts on ecosystem, this also entails other risks, significant risks. Extreme events occur more often, sea levels rising, food security is negatively impacted. And these are just examples of impacts that have been observed so far. The Working Group 2 report of the last IPCC clearly states that in recent decades, changes in climate have caused impacts on natural and human systems on all continents and across the oceans. It also clearly states that with future warming, these impacts, or the likelihood of severe pervasive impacts, is going to increase. But in addition to these observed and expected impacts of gradual climate change, we need to think beyond that. We need to embrace the possibility that in a 5 degree warmer world, which is basically what we're heading to under business as usual, we are reorganizing the climate system. And the reason for that is that parts of the climate system respond in highly nonlinear ways. These are the so-called tipping elements in the climate system. A tipping point occurs when a small change in forcing leads to a strongly nonlinear response. And that leads to qualitative change in that particular dynamics. The response might be reversible or not. The state might be monostable or there might be multistable states. But in addition to these different characteristics of tipping elements, it's important to note that we cannot expect these parts of the climate system to respond in a smooth and gradual way. There are several of such tipping elements in the climate system. Here you see a number of candidates. They concern biome loss, they concern cryospheric changes, they concern changes in the large-scale circulations of the ocean in the atmosphere. And human-induced climate change can basically push these past their critical threshold. Now, as became alarmingly evident last May, tipping is not just a theoretical possibility, it is reality. What you see here are the glaciers of the Amundsen Basin in West Antarctica that are currently undergoing irreversible retreat. They have been observed to speed up for the past decades, but what became clear just last year is that they have retreated into the deep valleys behind them, meaning that they're now undergoing irreversible retreat, and there's basically nothing that can stop the ice loss from this particular region. That will lead to global sea level rise of roughly 1 meter. It's still unclear how fast this can happen, but it is clear that it is going to happen. And it is also clear that with increased global temperatures, the likelihood of such events increases as well. This was called a new era of irreversible climate change. And you can easily imagine that if more than 300,000 gigatons of ice are dumped into the ocean, that will certainly have significant impacts on the ocean as well. Here you see a sketch of the thermohaline circulation. It's density gradient driven, so basically driven by changes in temperature and changes in salinity. And it can come to a halt, or collapse, as we say, when in the North Atlantic there's a significant freshwater influx, for instance from the Greenland ice sheet, or if there's a change in temperature. Now, I don't want to look at projections of when this collapse of the thermohaline circulation might happen in the future. It's really difficult to predict these tipping points. Instead, I want to ask another important question, and that question is, what if? So what if the Atlantic thermohaline circulation did collapse? What would be the consequences? We would surely see those consequences all around the globe. They reach from disturbances in the ecosystem in the Atlantic Ocean over changes in the Indian monsoon system to a reduction in oceanic carbon uptake. So these are just a number of these impacts of a collapse of the Atlantic thermohaline circulation. As I just said earlier, sorry, the next slide, please. Thank you. As I said earlier, a collapse of the thermohaline circulation is certainly impacted by a collapse of the Greenland ice sheet. The Greenland ice sheet is another tipping element of the climate system, and pushing the Greenland ice sheet across its tipping point basically means that it's going to melt down entirely. There was supposed to be a video showing how this process happens. This doesn't seem to work, but actually the mechanism behind this is really easy to understand. The mechanism basically means that if you lower the surface elevation of the Greenland ice sheet, it will warm, and that warming will lead to additional melting, and then in turn lead to more lowering of the surface elevation. So this is a self-enforcing feedback that basically drives that meltdown of the Greenland ice sheet. If it did melt down entirely, sea level would rise by 7 meters globally. And the threshold for this to happen has been estimated to be between 0.8 and 3.2 degrees of additional global warming. Now, this chain of events is really just one example that is to show that there are feedbacks between these tipping elements in the climate system. For the three that I just mentioned, the Greenland and Antarctic ice sheets and the thermohaline circulation, this could be the chain of events and the important processes at work. Tipping of Greenland means reduced warming, and then means freshwater input in the North Atlantic. That in turn will lead to a weakening of the thermohaline circulation. That will lead to Southern Ocean warming, and that will certainly influence the ice loss from Antarctica. Also, Greenland tipping means sea level rise, as we just saw. 7 meters of sea level rise globally, but especially on the southern hemisphere due to the gravitational effect. And these two sort of processes together mean that tipping of Greenland will certainly influence the tipping point of Antarctica. So what can we conclude from this? I think we need to think about business as usual in a different sense as well. Business as usual, that means a 5-degree warming by the end of this century. 5 degrees of warming, that's also the difference between an ice age and an interglacial. And clearly, during the last ice age, Earth looked very different from the planet that we live in today. So a 5-degree warmer planet will probably also look very different. And we can look at some of these changes with models. Here you see the long-term response of the Greenland and Antarctic ice sheet. And as you can see, this is no surprise since we just saw that the tipping point for Greenland occurs between 1 and 3 degrees above pre-industrial. So the Greenland ice sheet would become essentially ice-free with business as usual. And the Antarctic ice sheet would also significantly lose mass. And if you're interested in this particular tipping point, I invite you to come to the session on tipping elements in the Earth system at 11:30, just outside in room 4. So these are just some of the long-term changes. And we need to consider that, well, since the Earth system is so highly connected, that there are other changes that might be caused by the tipping of these specific elements that you see here on the map. Now let's put this into context. What you see here is the temperature evolution since the last glacial maximum. So 20,000 years of, well, basically the history of temperature. And on the right, you see the future scenarios. You see the RCP scenarios and the temperature evolution that goes with it. And there's one striking thing that immediately comes to mind, and that is what we're doing right now with the climate system is a really drastic change. Actually, we're changing the planet much faster than what happened between the last ice age and today. And if we now look at what is, well, our best estimates of when different elements, different tipping elements might cross their critical threshold. And it's important to, well, state again that it's very, very difficult to predict these tipping elements. So there's a lot of uncertainty that goes along with these ranges. But this is, to our current knowledge, the best estimate. So this is a compilation of these different thresholds. And as you can see, it makes sense to have the 2-degree guardrail. Actually, 2 degrees is not a really safe margin yet, because it means that a number of these tipping elements, a number of these critical thresholds would already be crossed. And under business as usual, you can see that most of these tipping elements would probably, well, flipped over. So I think business as usual on the long term needs to be regarded as a reorganization of the climate system. And I think it's important that we think beyond the gradual change and the impacts that go along with it. Thank you very much.
Thank you, Ricardo. I now invite Dr. Paul Leadley from the University of Paris-Sud to deliver his presentation. Dr. Paul is the coordinator of a multidisciplinary sustainable research program and has been a lead author on the IPCC. Thank you.
So thank you very much. It's a great pleasure for me to be here, and I thank the organizers for having invited me to talk about the future of biodiversity. This talk is based on primarily two pieces of work. The Global Biodiversity Outlook 4, which we carried out for the Convention on Biological Diversity and was published in 2014. And of course, the IPCC AR5 report, especially the Working Group 2 report. So those are those two assessments. And the main messages that come out of those assessments are that many organisms are already being affected by climate change. You saw that yesterday. But the model suggests that as we go into the future, those impacts are going to continue increasing, and they get much worse in the higher emissions, greenhouse gas emission scenarios. Secondly, an important point is that biodiversity can play a really important component of adaptation and mitigation, and we need to take that in account. And thirdly, and I'll come to that at the very end of my talk, is that pathways to remain within 2 degrees really need to think about how we're going to also protect biodiversity in those scenarios and the contributions that biodiversity can play to adaptation and mitigation. So I'm going to start with marine systems and go through that thinking. One of the things that we know about the way that the species respond to climate change is that they move, adapt, or die. And so what we know through the history of the Earth, and especially recently, is that species are moving in response to climate change. And here's an example from marine systems, and we can see that there's a great deal of variability between these different species groups, but some of these species groups are moving really fast. Phytoplankton, that's the dot way up there on the top, are moving at more than 400 kilometers per decade. That's really, really fast. And those species that aren't moving, what's happening to them? Are they needing to adapt? And adaptation usually comes with costs for species, or are they potentially even getting to the point where they might have some problems in terms of survival? And surprisingly, it's really hard move, adapt, or die. That sounds really easy, but to actually put that into models in any realistic way is really hard to do. But we're beginning to do it, and there's some really good work that just got published by Catuzzo et al. In Science that summarizes a lot about what we know based on scenarios looking into the future, looking at a low emissions scenario and a high emissions scenario, and looking at the effects of ocean acidification, ocean temperature rise, and sea level rise on ocean biodiversity. That's the top part of this graph looking at seagrass, mangroves, warm water corals, and others. And the bottom part of that graph that's looking at the ecosystem services that we get from ocean systems, like fisheries and coastal protection. And what you can see is on the left-hand side of this figure is that it's mostly yellow, and that means that the impacts are foreseen to be moderate under low CO2 emissions or greenhouse gas emission scenarios. And if you look on the right-hand side of that, you can see that everything is red or violet, meaning that we're really looking at an extremely highly impacted world, and not just in terms of the way that species are responding, but in terms of the ecosystem services that are provided by those species. So that clearly is illustrating that we need to avoid that business as usual high emissions scenario. The second point that I want to make about ocean systems is that conserving biodiversity is really important for adaptation. I'll just take one example. One of the most highly impacted systems already from climate change are warm water coral reefs. And on the left-hand side of this, you have a picture of the red squiggly lines are the net carbonate budget of healthy Caribbean ecosystem coral reefs. And where it's above the black line, the coral reefs are building, and where it's below the black line, coral reefs are degrading. And what that illustrates is that in a business as usual scenario, and where we don't protect biodiversity, and particularly herbivorous fish in this system, we could be at negative carbonate budgets or degrading coral reefs by the middle of the next decade. So it's not something that's going to happen way in the future. This is coming tomorrow. And the other slide shows that we don't just need to say, well, coral reefs are doomed. If we keep climate change to less than 2 degrees and we protect biodiversity, and again, in this case, herbivorous fish species, those species help protect coral reefs. And if we also reduce other stressors on them, at least these scenarios suggest that we might actually be able to maintain different but reasonably healthy coral reefs into the future. So this illustrates that both local and global efforts are required, and that biodiversity can play a really important role in adaptation. I want to jump now to terrestrial ecosystems. And this is, again, looking at this move, adapt, or die question. And in particular, we're looking at different species groups and the rate at which they can move across the face of the Earth. And I want you to think of the climate moving towards the poles. Your favorable climate is moving towards the poles, or it's moving up in altitude. That's a really gross simplification, but we'll say it that way. And if you're a person, you want to stay in your comfortable climate, you're going to have to move to stay in that. Now, I can do that pretty quickly because I can jump in my car and drive. Trees can't do that very well, and they have a really slow rate at which they can move unless people intervene. So basically around a few kilometers per decade. Some other species actually can move quite quickly. For example, most large vertebrates can move fairly quickly. And what we've done is compare that with the rate at which climate's going to be actually moving across these landscapes. And that's what's on the bottom of this graph here. So what you've got on the very left-hand side is the low emission scenario. And actually at the end of this century, species wouldn't have to be moving to keep up with climate change. That's really important. On the other side of this, if you look at the RCP 8.5, that's the high emission scenario, especially in areas that are really flat, and that's where climate's going to move really fast. That climate is going to be moving much faster than almost any species, except a few large vertebrates and some insects can manage to keep up with. So that means these species are going to have to adapt or die. And do we see any signs of that? And one of the things that we raised in the most recent IPCC report is that it looks like trees are beginning to die at the equatorial edge of their distributions. So maybe we are beginning to see the first signs that there are some problems with adapting, and maybe some species are beginning, at least individuals are starting to die. So what can we do about this? Again, one of the sectors that's thought about this most and is really working very closely with the scientific community is the forestry sector. And one of the ways that we can make these forests more resilient to climate change is to increase both species richness and genetic richness that in many cases, increases their capacity to resist climate change. The last point I want to make, and we're not going to talk about birds, is whether or not we want to maintain 2 degrees at all costs. And one of the problems in the 2-degree scenarios is that they rely heavily on bioenergy with carbon capture and storage. And that's a really serious problem in terms of land use. And if you look at these scenarios, they have major impacts on land use that are going to have very negative effects on biodiversity. And so one of the things that we did in the Global Biodiversity Outlook 4 was to actually look at scenarios that could potentially meet 3 major sets of global objectives. Stop biodiversity loss by 2050, meet the Millennium Development Goals, especially focusing on eliminating hunger, and keep global warming below 2 degrees. These scenarios suggest that they're extremely difficult to meet, but can be met with lower levels of bioenergy and carbon capture and storage than are in most of the current IPCC scenarios, and that those are much better in terms of biodiversity. And so to finish, and I'm going to skip my next slide as well, one of the things that we need to do is collectively work together much more to have a common vision of what the future should look like. And in that sense, IPBES, which is the International Platform for Biodiversity Ecosystem Services, which is the IPCC for Biodiversity Ecosystem Services, is now working closely with IPCC, including thinking about scenarios. The Convention on Biological Diversity and UNESCO are funding work to bring these 2 communities together, and I've just come back from a meeting in Japan in which we've been talking about how to get actors involved in building scenarios so that they actually feel part of the thinking about our future and thinking about scenarios. And of course, Future Earth is making a big effort to bring these communities together to think collectively about our common future. And one last word is that a lot of the talk is a bit about our common future and mostly thinking about our, meaning people. At least from my perspective, we share this Earth with a lot of other species, and our common future as we go through the next few days, we probably ought to thinking about not just people's common future, but our common future with the species that are on Earth as well. Thank you very much.
Thank you, Dr. Leadley. I would like to now invite Corinne Leclerc from the University of East Anglia, where she is director of the Tyndall Center for Climate Change Research, which researches on the interdisciplinary dimensions of climate change. She has expertise in the global carbon cycle, and we look forward to hearing from you.
Thank you. Thank you for the honor to be here today. This is the time of the conference when we start repeating each other, but I don't think anybody has actually yet shown this first slide that I hope is going to appear, or maybe I need to, here is the very latest data on the rise in atmospheric CO2. First measured in Mauna Loa in Hawaii by Scripps Institute of Oceanography, then South Pole, more recently the trend, global average for NOAA ESRL, about to reach 400 ppm. As you see here, this rise in CO2 results from the emissions of CO2, primarily fossil fuel burning now, with smaller contribution from deforestation and industrial processes. This rise is fast, 2 parts per million on average now, but it would be actually even faster if all the CO2 that we put in the atmosphere actually stayed there, and that's not the case. More than half of the CO2 emissions are absorbed by the natural carbon reservoirs, the ocean and the land, which then these natural reservoirs then offers a big service to humanity by slowing down the rate of warming. We know a lot about these carbon reservoirs. We know that in addition to responding to the rising atmospheric CO2, both the land and the ocean also respond to warming. And we think that response to warming will reduce their efficiency in absorbing this extra CO2 we're putting in the atmosphere. Our current knowledge is based on understanding processes, and it is also based on observations from the past. The knowledge has uncertainty, which are, to a large extent, accounted for in the projections of climate change, and our knowledge also has limitations which are not. What I'm going to show now is this is the trajectory of carbon emissions, the main driver of this rise in CO2 from Ciudad laboratory. I'm going to show you different possible futures and discuss what they include in terms of carbon feedback and what they imply for the carbon cycle and management in general. Here is a set of emissions pathways which are consistent with limiting climate change to 2 degrees. These projections do include a carbon cycle feedback, which we think will amplify the warming by about 10% this century based on observations of the past millennia, with a full range of estimates of 5 to 30% amplification. I contrast this here with the little wiggles that you see in the right here, which what you're looking at are the variations in atmospheric CO2 during the last roughly 1 million years during glacial cycles from Vostok and Epica through 8 glacial cycles when the Earth was at most 2 degrees warmer than today, and mostly colder, actually. This is one of the pieces of evidence that demonstrate that there is a carbon cycle feedback. There were some rapid changes during that million year, but what is the main characteristic of these observations is that these changes are bounded. There is an upper bound and there is a lower bound, and thus they are relatively stable within the range of our knowledge, and that these changes are consistent with the feedbacks from observations in the past millennia, decades to millennia. What the projections do not include here is the potential implications for the preservations of the carbon reservoir that are implied by the very heavy management that are on the very high right-hand side here, the so-called negative emissions, which mean managing the land to a level where we have a net absorption of carbon out of the atmosphere. The multiple uses of land, in particular the co-benefits that we can extract from it, including in terms of preservations of the carbon reservoir, food production, bioenergy with carbon capture and storage, need to be explored further going forward. I now show the other extreme of the projection. This is a set of emission pathways that are consistent with a fossil fuel intensive world leading to warming of 3 to over 5 degrees, which also includes a contribution of warming from the carbon cycle feedbacks in the same way that the lower scenario does. We don't have a good analog for what such a warm world would look like in the past. We do have evidence from much deeper times, much warmer climate. The one I show here is from the PETM about 56 million years ago. Much warmer climate, different continent configuration, much less ice, if any at all. But nevertheless, this is an analog where we have actually observed a pulse of carbon to the atmosphere was inferred, actually not observed, inferred from isotopic data, which amplified climate. In that event, perhaps by a further 4 to 7 degrees over several thousands of years, possibly from the release of marine methane hydrates or from the release of carbon in terrestrial permafrost, or both. The release of methane hydrate leading to such a pulse is unlikely this century, but the mere presence of this signal in the geological past suggests that there is a risk of destabilizing the carbon pool and that this risk increases as temperature goes up. The carbon release from thawing permafrost The next slide, please. Thank you. The carbon release from thawing permafrost is the largest carbon feedback that is not yet included in climate model projections. The IPCC Working Group 1 assessed that this release would likely be between 200 and 900 gigatons of CO2, that is 50 to 250 gigatons of carbon for the red scenario, RCP 8.5, but with low confidence only because of limited evidence. This amount of carbon corresponds to 10 to 15% at most additional warming in this scenario, so a significant contribution, but not a game changer. Everything that I have heard here in this conference yesterday supports this analysis and suggests, if anything, that the release would be on the low end of the projection. A new finding, almost a discovery actually, from the recent carbon cycle synthesis is the very important role that semi-arid regions play both for the trend in the carbon uptake and for its variability, and that is that variability and trend are strongly affected by circulation-driven changes in rainfall and temperature. In the oceans, signals are emerging from repeated ocean CO2 measurement, but we still actually have quite an unclear picture of the trends in the Southern Ocean that was mentioned yesterday, and I would say really just a partial understanding of the responses of the marine carbon cycle to multiple pressures on ecosystem, including ocean acidification. So in summary, our current understanding is that climate change will affect carbon cycle in a way that will exacerbate the increase of CO2 in the atmosphere. The carbon cycle feedbacks are mostly included in climate projections, with the permafrost feedback being the largest one still missing, but beginning to be better constrained. What is less clear are the risks at high climate change, the interference with the managed land, the more complex effects of ocean acidification, and very importantly, the changes beyond the 21st century. Thank you.
Thank you, Corinne. I now invite Dr. Shobhakar Dhakal, who is at the Asian Institute of Technology in Thailand and has been a coordinating lead author of the IPCC Fifth Assessment. His areas of expertise are in urbanization, cities, climate change mitigation policies, and modeling. Dr. Dhakal.
Thank you, Purnamita. Ladies and gentlemen, many friends in the room, very, very good morning to all of you. This morning, I'm going to talk with you about the future cities in our carbon-constrained world. Next slide, please. We all know that cities are important. A recent assessment in IPCC and number of other assessment, notably global energy assessment in the urban section, also have shown that cities are very important. Somewhere between 71 to 76% of the global energy-related CO2 emissions comes from cities. Well, they have some accounting different aspects. How do we account city? But nevertheless, cities are important. If we are going to add the embodied emission in the consumption goods and services, then the role of cities and the role of urbanization becomes much more stronger than what we see from the direct emission or the direct energy use. At the same time, we have seen that the emissions from cities are very diverse. We have 50 tons of CO2 per person in the Las Vegas down to less than 3 ton of CO2 per person in New Delhi. You see a wide variation of the CO2 emission across cities, which are not always very, very easy to explain because a number of different drivers really act on it. So the direct comparison of cities' emission is usually very, very hard, unlike the nation states where the boundary is relatively closed. Now, there are different drivers. These drivers are physical, economic, social drivers, and the combination of these drivers give a particular carbon trajectory from cities. We fairly know the individual drivers. We know technological drivers. But our knowledge about systemic drivers and the integrated effect of those drivers which really work together to give a distinct carbon outcome of the city, that interaction and the collective effect of the driver is something we have less understood. We know that spatial drivers are very important. We have shown that higher density reduce emission, mixed land use reduce emission, increasing accessibility and increasing the connectivity of infrastructure and services reduce emission. But in reality, density alone is not sufficient to reduce emission because many of the drivers really work in very, very different fashion. So how do we understand the collective effect of this driver is fundamentally very, very important for us. Now, global urbanization has been unprecedented. We all know that. We have roughly 54% of the global population living in the urban area. We are heading somewhere between 6 to 6.3 sort of billion urban people in next couple of decades. By 2050, from now to 2050, from 2014 to 2050, we are going to add 2.46 billion people in our urban areas, cities. Now, in that 2.46 billion people, you see that almost 87% is expected to be coming from Asia and Africa, which are predominantly the developing countries. So you see that in the future urbanization pathways, the role of developing country, rapidly urbanizing regions are extremely important. Now, this future urbanization and this unprecedented urbanization would have drivers and emission implications for within city, and also their implication goes far beyond what city can exert under pressure. We have seen that urbanization increase income have a direct correlation with the emission. We have seen that in the history, and also we expect that to continue in the future as more and more the developing countries and developing cities really urbanize. And also we have seen that the per capita final energy consumption in cities in the developing countries are much higher than the national average. Why we see that the per capita energy in cities in the developed countries are relatively less than the national averages. What it means is that future urbanization is going to happen in the developing countries, cities, rapidly urbanizing regions where the per capita emission or per capita energy in those cities are going to be much higher than the national averages. Now, something very important for us not to forget is the infrastructure. Recent studies have shown, at least one study showed very clearly that the infrastructure stock in the developed countries per capita could be 5 times higher than the developing country or 3 times higher than the global average. Now, if the developing country catch up with developed countries in terms of infrastructure stock per capita, we are going to see huge embodied emission imposed by that infrastructure, which could be in the range of 350 gigaton of CO2. 350 gigaton of CO2 is little over 1/3 of the global emission budget, what we have from now to 2050. We talk about 1,000 gigaton of CO2, and you can see that over 1/3 of that means infrastructure, embodied emission in infrastructure, which is largely in cities. So you see that infrastructure and the urbanization is a big elephant in this carbon mitigation discussion. China is a perfect example to illustrate that, the urgency and the opportunity. You see that the Chinese government unveiled ambitious plan last year to increase urbanization rate from 53% to 60% by 2020. Then, of course, there is a lot of quality factors. For example, public transport share will be increased. Can I have next slide, please? Increase renewable energy share will go up. Building will be more efficient. There are a lot of quality factors also there. But essentially, we are talking here $6 to $7 trillion investment, and we are talking about need for infrastructure not to be locked into the particular trajectory which are energy intensive or carbon intensive. So importance of urbanization and guiding the urbanization that is going to happen from now to next couple of decades is important. That doesn't mean that retrofitting or re-engineering our existing cities are less important. We have seen that, and also many studies have shown that increasing the system efficiency is very, very important for cities. We have been fairly successful in looking urban system in a very, very sectoral fashion, buildings, transportation, but what we have lacked is try to see city as a unit where all these different things really come together and to maximize the system efficiency, taking some opportunity for infrastructure replacement cycle in cities, reorienting consumption and public choices. We have a long way to go. And one more important area is developing effective climate change mitigation action plans. IPCC and many other studies have shown that city has been important drivers, but the evidence of climate change mitigation remains still very, very sketchy, and we still have to see. And that process has to be a bit more effective because cities are looking at the end of the pipe of solution or energy efficiency, but at the moment perhaps not thinking of systemic effects and some large-scale integration needed for a deep cut in CO2 emission. So there are no silver bullets, and every city has to actually devise its own plans. Now, there are many challenges to overcome. One big challenge to overcome is to move from incremental to transformative change in the cities and how we develop our future cities. A very important challenge is to address the problem of the dependency of mitigation solution on the size of the cities, level of governance capability, and the high income. We have seen that as cities are small, as cities have less income, governance structure is weak, there it's very problematic, and most likely these are the cities where most of the urbanization is going to happen in the future. So that means addressing the governance paradox. That means providing capacity to govern in those places where mitigation opportunities are higher. That governance paradox and the policy fragmentation for a systemic change, which has more opportunity in cities, they are significant challenge for us to overcome. And one very important point I also must touch upon is smoothing the easy entry point for cities, particularly in the rapidly urbanizing and developing region. Best practice technology, local co-benefits, these provide very strong smoothing the entry points for cities which must be tapped. With this, let me touch upon the key message. I would like to once again repeat our ability to deep cut global greenhouse gas emissions really depends on what kind of cities and towns we build in the future and how urban dwellers embrace carbon mitigation. We do have large window of opportunity in guiding new urbanization, especially in next 2 to 3 decades, but this window of opportunity is narrowing and fast closing. So I think we can't delay acting on that. And low carbon city must address greenhouse gas emission within its boundary, also outside its boundary. Supply chain, infrastructure link, all these embodied emission is extremely important. Now, we have said many times that systemic and integrated mitigation solution is essential, but in order to do that, governance and the policy fragmentation must be addressed. There is huge role for science in order to provide the solution-oriented knowledge. Scientific community have done excellent work in IPCC. We had a new chapter in IPCC Working 3 for the first time around human settlement. Global Energy Assessment conducted fantastic work on urban system, and Urban Climate Change Research Network, which is a network composed of over 600 researchers at the moment, is about to deliver second assessment report, which will be sent to the Cambridge University Press very soon and will be released by the time of the COP. These are very interesting scientific initiative, and I think this is a time that science should provide more solution-oriented knowledge for local policymakers to act and help them to make future cities, low-carbon future cities. Thank you.
Thank you, Shobhakar. I thank all the speakers for their contributions to the session. And I now move on to the panel discussion. May I invite the panelists to join me? We have a rich and diverse expertise on the panel for a discussion on what the contours of a resilient global future could possibly be and how one could reach there. We have three panelists: Johan Rockström, who is the director of the Stockholm Resilience Center and a professor in environmental sciences at Stockholm University. We have Alexandra Gavilano from the University of Bern, Switzerland, coming from the Environmental Policy Analysis Division. And we have Luis Fernández Carril from the Climate Change Research Program at UNAM, Mexico. To begin with, I would request the panelists to share their thoughts on what the contours of a resilient global future could look like in about 3 minutes each, and then we will take it from there. May I first invite Johan, followed by Alexandra and Luis, to share their thoughts on this.
I think it's been clear from the science that has been presented this morning and yesterday that we can conclude something quite dramatic as a scientific community, that we as humanity are now in a position to disrupt the stability of the entire Earth system. And that this requires, which has been pointed out by Ban Ki-moon, it's been pointed out by Yim Yong Kim of the World Bank, by Angel Gurria at the OECD, even by Christine Lagarde of IMF, that we need a new relationship between people and planet. And that is all about the contours for a new resilient future. And to summarize, in my mind, the three fundamental scientific insights that leads to this dramatic conclusion of a complete new relationship and therefore a complete transition into a new logic where we need to develop as humanity within a safe operating space on a stable and resilient planet are the following. The first is clearly that we have the scientific evidence that we've entered the Anthropocene. We're now the largest force of change at the planetary scale. The second is what Ricard has summarized so eloquently earlier, that the response when we're punching the planet is not linear, it's not incremental, it's therefore not predictable. The universal response is really surprise. Tipping elements is a real risk and therefore also something that we need to relate to by creating the redundancy and buffering capacity to avoid ending up in the way we've basically designed our entire economic and governance logic, optimization and efficiency, when in fact we need to have redundancy and flexibility and diversity, the way we define resilience. The third and most humbling insight, though, is in my mind that we have so much data today to say that we can define the desired state of the planet for our prosperous future. We know that the Holocene, the remarkable, not to say the almost miraculously stable equilibrium of planet Earth for the last 12,000 years has enabled humanity to prosper into the modern world we know it. Pope Francis writes about this in a very eloquent way, aligning itself with science, talking about the need to now safeguard creation, in our words, basically a resilient Earth system. The 2 degrees target, in fact, is a climate guardrail to preserve a Holocene-like state of the planet. And I think that Corinne, in a very nice way, summarized the fact that the way the Earth system is responding so far to our energy imbalance or abuse is actually to apply all its biogeophysical processes to remain in the Holocene. Earth system is our best friend, applying its processes to remain stable. And if you add these 3 things up, the Anthropocene, tipping elements, and the Holocene, that leads, in my mind, to 2 conclusions. One is that we now need to address Earth resilience. We need to govern and manage and innovate for Earth resilience. And that leads, however you twist and turn things, to the need to define a safe operating space. And we've defined that, or call that framework, planetary boundaries. Ségolène Royal, in her speech yesterday, actually equated that in a very nice way to the need for us to become planetary stewards. And it is all fundamentally about maintaining the negative feedbacks, the flexibility, and the ability of the Earth system to actually dampen and continue to be stable at planet Earth. So if planetary boundaries becomes a defining framework for a safe future for humanity, I'd just like to emphasize, which just complements what other scientists have said already, it means that it's not enough just to focus on reducing emission of greenhouse gases. It really means an integrated approach where we manage social, ecological systems in a way that continues to allow not only for carbon sinks, but for the flexibility to adapt and transform. And one way to define this in a very technical way is that, if you look at every IPCC assessments in 1990, the uncertainty range with regards to climate sensitivity has remained remarkably stable between 2 and 4.5 degrees Celsius at a doubling of greenhouse gases. Many accuse this to be science is still uncertain. I would strongly criticize that conclusion. It is rather a range representing risk, as Corinne and Karen pointed out, but it's also a range of resilience, because the range between 2 and 4.5 is really determined by our ability to become stewards or to be stewards of the systems that can allow us to avoid the feedbacks that take us to 4.5 degrees. So I think we should use the uncertainty range as we learn more and more of how the complex Earth system operates as a communicative language of saying this is really resilience at play. Avoiding 4.5 degrees is not uncertainty, it is about resilience. Choosing a sustainable path is about resilience. And just to close then, the policy domain is understanding this. Ban Ki-moon is actually launching a global resilience initiative at the climate COP to be able to represent this. Thank you.
Resilience has become a core concept now as a tool for analysis and also in the development agenda. But most importantly, it has now become a sort of paradigm in political practice. And this is the part that is becoming more interesting and dangerous also. In political practice, we see resilience that is being used as something desirable, something good, something normative in itself, something we strive for. But actually, and we have to remember that we want to avoid this, actually. And now, to explain this and to allow me to elaborate, 30 years ago, well, almost 30 years ago, with the Brundtland Commission, issued Our Common Future, and they coined the term sustainable development, which was defined as the development that does not compromise the needs of the present generation or the future. If this is true, then sustainable development is no longer possible. Now we're endangering this generation and the next generation. Furthermore, 5 years after the Brundtland Commission issued the report, the Framework Convention was created, and as you know, the objective of the convention was to avoid dangerous interference with the climate system. Now, we are here in this conference called Our Common Future, and now we added 3 important words: under climate change. Are we normalizing this change in political practice? We have seen how there is a shift in policy, in politics, to normalize, to become operative as people will need to become resilient as something good. And actually, this is not something we desire. We desire that the governments of the world do something about this, and soon, because time is running out. So if we allow resilience to become the paradigm in political practice, we're normalizing, we're welcoming the new normal. And as a recent declaration of the Southern Pacific Islands issued a couple of weeks ago, we refuse, quoting, we refuse the new normal. We don't want a resilient global future. What we want is to avoid it. It is not something to be desired. So in political terms, aside from perhaps to use resilience as a analysis, system analysis, in political practice, we don't want, in the present moment, I'm preparing for COP21, we don't want resilience, we want resistance to climate change.
Well, I strongly agree with that, and I think that's one of the biggest problems. I always considered the description of contours of resilience of our common global future as a justification of still having the problems of finding solutions to act now. Well, thinking of what does it actually mean, and I'm quite happy that you as well as other speakers already have highlighted this, is what do we mean with a resilient global future? And I also strongly agree and derive from this description that we actually want for all livings and all ecosystems as we have them now to be able to survive and also exist in the future. But do we actually really enforce this kind of thinking also from the scientific community? Are we actually sure that something will happen December this year, also with all the inputs that we are giving? Fact is that science is only accountable towards the scientific truth. We're not directly elected by politicians, we're not directly elected by society. So we mostly keep on giving inputs to decision makers. From my view, and after having heard these two inputs, I strongly try to enforce the scientific community to go one step forward and give more than just scientific inputs, but actually recognize our position we have got and acknowledge the power the scientific community has got from also the political view. Being working in environmental politics now, I see the struggle of implementing new scientific insights that we get, and it's quite a lot that comes daily from all over the world. So we maybe just have to start to take more action as well, not as activists, but by supporting the movements that we see in society, that we see in political dynamics worldwide. Should it be a fossil-free university that we just can support by being a professor, by being a researcher? Could it be that a conference like this one, with the topic of climate change, should have no meat on the menu? Or should we use the plastic bottles for the entire week? These are things and pledges we can already have now, and I think as a young and ongoing researcher, I think this is the first step we have to also share with the entire world. So we all know that other social problems like wars and disequalities because of propositions and ideas of different lifestyles will go on. About climate change, we have solutions, we have ideas, so we should give more impact to the decision makers to really take action now. It still will have other problems that we don't know how we will combat them, like micropollutants, like GMOs. So why should we not take more action and go beyond just giving input? I thank you very much for this.
Thank you. Thank you. Very interesting views. We've heard earlier today, most of the speakers agree that individuals and countries working together can bring about desired change, whether that be through a resistance approach, a resilience approach, or in terms of who we are accountable to and how, and what actions we take. I would like to now request each of our panelists to, I only have 2 minutes to give to each of you, but to, in those 2 minutes, respond to each other, give comments on the views you've heard from each other, focusing particularly on what could be actionable points for getting to a resilient future.
Yeah, let me start by saying that I agree with you, Luis, that there is, and I would really emphasize this, a wrong interpretation of what resilience is. Resilience has become some kind of inflated buzzword. Sustainable development is always good. Resilience is certainly not always good. The Mugabe regime in Zimbabwe is very resilient indeed, and you need to break resilience many times to transform in a desired direction. I also really want to emphasize that what you're criticizing, in my mind, is really adaptation, saying that we have, unavoidable climate change, our only path is adaptation. Resilience, as I try to emphasize, is about, number one, persisting, resisting, managing planet Earth in a way that we keep the Earth system in its Holocene equilibrium, which actually means staying way below 2 degrees Celsius, as showed by Ricarda. But it also includes the capacity to be adaptive under changing conditions. So it's certainly not a sort of say a give-up strategy. So I think it's important to stay to the scientific definition of resilience. Then on I think a bit inspired from the way this discussion goes, I find it very interesting to see that the social dimension of resilience, the human dimension of resilience, is, I think, the big opportunity at this stage. We're starting to see a change of atmosphere when it comes to the discussion on climate change. Climate change is now much more a question of opportunity. There's more evidence that we can actually, in a transition to a decarbonized future, have healthier, democratic, more technical, cooler, more effectively poverty alleviated, more resilient societies, and that's a more desirable future. And that we're starting to see a large enough minority in the world, particularly young people, rising to this opportunity. And that, to me, is social resilience at play. The People's Climate March last year is one such attribute. So one shouldn't only emphasize on the physical side of this, as Karen pointed out, the social dimensions of resilience and what can tip the world in the right direction is really exciting as well.
Well, as I said before, the thing is that there is a definition for resilience as a system tool, as a system analysis tool, but in political practice, that it doesn't matter at all. In political practice, in discursive practice, resilience becomes a term that it may be used for many different purposes. It may be used to describe a feel-good situation. For example, when the typhoon hit the Philippines, they were saying, I remember an interview with a photographer that said, oh, now everything is destroyed, but they still smile. They are very resilient. Now, about the same event, the typhoon, the government of the US said, we know the Philippines has a history of being resilient, for example, in the Second World War, so now we urge the Philippines to become more resilient. And we can think, well, what does the President of the United States want to say with that? And after that, the USAID started a resilience program in the Philippines with Procter & Gamble and Coca-Cola. So, and there are pictures, you can see the photographs, of people who were severely damaged by the typhoon with a Coca-Cola in their hands and the products of Procter & Gamble on the other. And the representative of this company is saying, resilience development here, we can see it. So what is resilience? Is it to sell products? Is it to have a feel-good attitude towards negative disaster? Or what else can it mean? And that is exactly the problem, that we cannot clearly define the concept. Perhaps in science we can, but not as a political practice. And that is precisely the danger, because it can be used as an excuse for ideological use, for neoliberal use. So that is where we have to pay attention who is talking about resilience. The World Bank, the IMF, etc. How are they using the term?
Well, I think that's quite important as well, as you see. And of course, As also it has happened with the term sustainability, it will be used in other forms. What is especially important is when it comes to decision making or in the COP conference, that the term is being explained by those who give the inputs, by the scientists that are present and by the policymakers. So what is the aim of being resilient? What is what we all need for us? I think there is where we start in general. So I agree with that it will be malused also in the future, but that what we actually want and what stands behind it is to be able to go on. So we can recognize that in different sectors as well, as you have mentioned. I think in general, I also strongly agree that the different aspects and tipping points that we are going to reach soon from now will have a great impact on the entire resilience. We will be confronted with new challenges that will make it very hard for us all to even think about what is resilience for ourselves, for our own personality, and how do we want to live. And will we be resilient to also in developed countries leave things behind that we're now used to? And this will be part of the resilience and of the combat of the entire globe, I guess.
Thank you very much. I think that's been a very interesting discussion. Final big hand to all our speakers. It's been a very interesting session, and thank you all for your contributions. I now hand over to Dr. Susanna for announcements.
Thank you all. Just a few housekeeping announcements. We are a bit late with the plenary, but now we have a coffee break until 11:30. We will then have the large parallel sessions, and they will be in the same rooms as yesterday. So this room, room 1, on the same floor, room 2, also room 4 in the mezzanine, room 11 and 12 at the basement level. And then we will have the lunch break with the poster view. This will be until 2:30. And please make sure you buy your metro tickets in advance, because yesterday we had some queue for buying metro tickets. And be aware that the next parallel sessions will take place both at UNESCO and at UPMC, starting at 3 p.m. at the University. And I also have an announcement. We will contact you by email to make sure that we can post the slides on the website of the conference. I would also mention that for one session, which is 4418B, Information for Decision Making, this session is taking place from 3 p.m. to 4:30 p.m. at UPMC. So please check the program on the website, which is more up-to-date than the program which is printed. So thank you all, and see you soon. Thank you.